Hello again and welcome back. This is Module 2 of Banishing Technical Debt Practice Guide. In this fairly straightforward module, I want to provide you with a technical debt overview, starting off with looking again at those two terms we used in Module 1, that of incremental and iterative approaches to product development. So let's make a start right away. Okay, so iterative development recognizes the fact that in all human endeavors, we will probably get things wrong before we get them right. And that's the nature of the beast, if you will. But that's not all. You see, iterative development also recognizes we will probably do things poorly before we do them well. Think of anything you've started for the first time ever, perhaps learning a musical instrument, then you'll know exactly that your learning was iterative. And that we use multiple passes to improve what we are building to converge ultimately onto a good solution. So iterative development has uncertainty in not knowing exactly how many improvement passes are required. Perhaps you could see that as a weakness, if you will. However, if you're using an adaptive process such as Agile, then you'll know that exactly how many sprints we need is not in fact a huge disadvantage after all. I draw your eyes down here to the model of analyzing, and then in Agile, analyzing the design, perhaps developing an early prototype, and then you test it and you refine the tests, and ultimately you deliver. So in effect, these first three boxes are carried out using sprints. So an incremental development breaks the product into smaller pieces. So we build a little and then learn a little from each piece is to survive within its environment. So if you're developing some handheld device, that's the environment within which it's got to survive, if you will, and then adapt on what we have learnt thus far and continue to build more of what we have learned. So Agile combines both iterative and incremental development. There's our chum, the product backlog down there, like I say again, can be used perfectly for physical and non-software projects if you choose. So a working product increment is created during each sprint to quickly validate product feature assumptions. For example, the way in which features work together and how they should be laid out, for example, in the product controls, whatever they are. What we'll have, therefore, is a valuable product increment at the end of each sprint, as Agile would call it, potentially shippable, whether or not you ship it to the customer or not. And the sprint end has included or is integrated and tested with any previous developed features. So sprint 3 could develop a certain number of features, and in sprint 4 you would build on them or integrate with the previous features, is the point I'm making here. So here's how this might look like as a graphic. Here's sprint 1, which the team will go around the loop of building, designing, analysing and integrating, if appropriate, whatever that product or products are, along with testing them. At the end of each sprint, you'll get feedback, as I showed you in Module 1. You'll then adapt what you're doing, and that would be the outcome of your first increment. And then you can start on the second sprint, and the process continues, as you can see. And the reason for this background information is that I want you to be able to manage and minimize technical debt, no matter what product or service or industry or specialism you're involved with. So let me repeat again. The focus here is on banishing technical debt. And my audience are certainly those involved with the business itself, or project managers or engineers or specialists. And I will continue making the point that technical debt affects all industries. That is the development of any type of product or service, not just software. Here's our hero, Ward Cunningham, upon whose giant shoulders I stand, who coined the metaphor technical debt way back in 1992. The way he said it was that shipping first-time code is like going into debt, and this was the very powerful metaphor that opened people's eyes. A little debt, he continued, speeds development, providing it is paid back promptly with a rewrite. Here he was obviously referring to code, so you could call this redesign or refinement, if you will, for non-software type products. I'm sure you can think of various examples that you've noticed or used or even worked upon, in that very often the first version of something that's shipped out, anything from an automobile to a kitchen utensil or even rocketry, as each launch proceeds, pun intended, then you will get better and better at whatever it is you're creating. The danger occurs, said Ward, when the debt is not repaid. You see, every minute spent on not quite right code adds interest on that debt. Can you imagine a mechanical part that was either used cheaper materials because it could be obtained quickly, or it went into production even though the mechanics hadn't been refined properly, that will be a debt that needs to be repaid. And what we mean there, of course, is improving the mechanical design in that particular example. Entire organisations can be brought to a standstill under the debt of an unconsolidated implementation. And here's just an example of a typical car. Just look at all of those components in there. Now, I'm no mechanical engineer, I have to tell you, but even as something as complex as the launch of a new car model will have a huge amount of products contained within it that all need to work to meet their desired features. And I'm sure you've read in the press where from time to time, no matter which manufacturer of automobiles, when they launch this year's latest version of a particular car model, it's usually got improvements and refinements. Not just bug fixes, but actually making a better car for the driver from what they've learned. This is a classic example of Ward Cunningham's metaphor when he talked about interest on that debt. So let's stick to Ward's original idea of this being used for software. Creating software fast to get fast feedback is a good thing. Replace the word software here with product and it will have exactly the same meaning. The first step, therefore, is that the team and organisation must be vigilant in repaying their technical debt as their understanding of the business domain improves. Here the word business domain could merely talk about the environment within which the product is being used, or the business environment within which it's being marketed and sold, or both, frankly. The second step then is the design and implementation of the system needs to evolve to better embrace that understanding. Here we can see iterative and incrementation playing a part, whether for software or physical products. But before I go any further, if I'm not careful, you'll run away with the idea that technical debt covers just about any mistake or issue or problem, and that's not true. Ward went on to say that technical debt should not refer to a team member, for example, in other words, team skills or business immaturity of a particular organisation or department, or even process deficiencies that may possibly lead to sloppy design, poor engineering practices, and that could refer to any industry, not just engineering, and a lack of testing. Certainly not testing enough will cause technical debt, but it's not the reason for technical debt in the first place. You see, these other types of debt, quote unquote, can be eliminated by proper or better training, sound business decision making, and proper application of technical practices. These are not technical debt per se, but referring to other types of debt that you might have. And I'll give you some more examples in the coming modules. For now, just be aware that there are three broad types of technical debt. The first is called naive technical debt, which, as its name suggests, is we've added technical debt because we didn't know any better, if you will. There's reckless debt, which, for example, would be just getting things out the door quickly without thinking it through, and something called unintentional debt, which is the hardest of all, if you will. It's where you find technical debt is present in your product or service, but you never intended it to be there. Don't worry, I'll be taking each of these three types and breaking it down into more detail later. So in this fairly short module, I've got one question to ask you, and it's an important one. Can physical products, and I've used that in the broadest sense, learn from Agile? And certainly from the development of software from where technical debt emanated? And the answer is positive. You see, applying Agile development concepts to product development, whether or not you're using pure Agile or merely adapting or adopting some of the ideas that I've already discussed, such as iterative and incremental approaches, will open new opportunities and revenue streams. Any manufacturer or organisation that creates products or services today is missing a huge opportunity here by not learning more about how technical debt can be managed and controlled. Indeed, faster time to market and continuous improvement leads to greatly compressed production time, but it comes at a cost, as I've discussed already. The stages of software development, in fact, are very similar to physical product development. Both For example, containing an initial vision or strategy, along with a plan, of course, a working design, robust testing, and iterative refinements before an end product is reached. Now, I've never worked in the car industry, but I'm sure in their design and development labs, they'll have early prototypes, they'll put certain components in wind tunnels, for example, to check their aerodynamic design, they'll be testing brake systems, the list is endless. And all of those will result in iterative refinements, even before the public knows that a new model is to be launched. So you need to create a culture of change and collaboration, and to try as best you can to put aside titles and work grades and work together collectively across departments and roles. The word collaboration here is key. You see, as you learn more about technical debt, as I take you through these various modules, you'll learn that collaboration across the various different specialist areas within an organisation is key. And indeed, in the final modules, I'll give you very precise examples of how that can fail and how it needs to work to minimise technical debt. You'll also want to encourage feedback from various stakeholders, users, customers, other departments or groups within your organisation, to feed back into the design and test process. Getting this feedback is absolutely critical and crucial, and that may be a slight deviation from how you run projects currently, particularly if you're using more traditional methods, which after all try to resist change as much as possible and have very robust systems for analysing change before it gets anywhere near being considered. Quite different, if you will, to the way in which Agile approaches product and service development. So what you're looking for here is prioritised features. There's our product backlog, if you will, prioritised in terms of business value. And these ideas and approaches will not only help to eliminate technical debt, will be feeding prototype and beta version products using empowered teams and the use of Agile sprints. Now, I'm old enough to remember the first moon landing, some 50 years ago, if memory serves, and I'm absolutely delighted the huge steps within the last decade that have been made by Elon Musk and SpaceX, to name the most obvious one, and others, to actually go back to the moon and Mars and beyond. For me, that makes compelling viewing. And I have to ask you, when you look at the way in which Elon Musk's rockets have evolved and developed so quickly over a breathtakingly short period of years, although I don't know this as a fact, you can almost bet that SpaceX is using some form of agile approach alongside traditional planning. It's only recently I learned that they did an update into how these fins at the top were actually attached to the body. Probably quite an important point. And you can bet your life that they're using very highly focused, empowered teams to get this impressive piece of technology up and running to meet SpaceX goals. Of course, SpaceX isn't the only company. I'm delighted to see others like Boeing and Richard Branson's approaches, all slightly different, are all in the running. Altogether, there's probably about 100 small rocket companies, if you will, all helping to contribute or go into competition to help win the space race. And you can bet your life they're probably using some form of agile approach. Certainly, they'll have prioritized features that drive the launching of their new rocket systems. So with that positive note, let's you and I keep focused on technical debt, because in Module 3, you and I will be looking at technical debt symptoms, liabilities, and the different types of technical debt. So thanks for your time and attention. Do meet up with me again in Module 3. From me, Dave, it's bye for now.